Hello everyone, welcome to the lecture series on the concept Foundations of Algebraic Structures and Number Theory. So in this lecture series we are going to start a wonderful concept algebraic structures, and further in the coming series we will work on number theory. Today we will discuss a lot on the fascinating world of groups and rings in algebra, which comes under mathematics. I am Dr. A. Stephan Antony Raj, Associate Professor, Department of Mathematics, working in SNS College of Engineering, Coimbatore. Welcome to the series. Algebra and rings in algebra. So, in your school level, you would have discussed or learned about sets, subsets, like kind, and again like groups. Further, you may be wondering why we study groups in the higher education also. Groups and rings in algebra plays a wonderful role when it comes to computer science field. Because algebra, a fundamental branch of mathematics, explores the relationship between groups and numbers with connected to rings. Two essential algebraic structures that like rings and groups underpin many mathematical concepts. So let's begin our journey into this wonderful interesting subject, rings and algebraic groups. So, understanding groups. First of all, to start with, let us understand what groups are. A group is a set of elements combined with a binary operation that satisfies four key operators like closure, associativity, identity, and invertibility. First of all, what is closure? So, what is associativity? Let's see one by one. So, closure means that if you take any two elements in the group and perform the group operation, the result is also an element of the group, like how you learn in sets. Suppose if there is an element if you take two elements in a set, the product or the multiplication or addition, suppose whatever operator you take. For example, here in closure we talk about some binary operator. So, its binary result should also lie in the same set, or here we have same group. Okay, I am just trying to connect with set theory what you would have learned in school level. Then associativity means that the order in which you perform operations does not change the result. Then third one is identity. Identity refers to an element in the group that when used in the operation with any other element leaves the other element unchanged. For example, for addition, let us take for addition its identity element is 0, and for multiplication the identity element is 1. The last one what I am trying to discuss here is the fourth property, that is invertibility. So inverse, in general we call inverse. So invertibility means that every element in the group has an inverse, which when combined with the original element under the group operation yields the identity element. So these are the four fundamental properties a group should have. Okay, these properties are what it gives a structure to the groups. Okay, so that's why we give more importance on these properties. So you may wonder how I am going to connect these groups into computer science or its applications. Further on, moving further into these kind of content on these ideas, we will be discussing how it is getting connected to computer science field. So thank you for listening. In this first lecture, we started with the concept of groups. In the coming lectures, we will talk about further more on this and also rings in algebra.